Hi guys, hope you're doing good. In this video, we're going to learn about Relational Database Management System, that is RDBMS. Now here, first let us see what is database. Database is an organized collection of data that can be stored in a format of electronically, right? So whenever we want to store our data electronically and retrieve it and use it whenever we require, we'll be using database. Now, whenever there are complex data to be stored, we all usually develop right formal design and modeling techniques. Now, next, what we are going to see is DBMS. DBMS is a software that interacts with the database and the user and then helps you to store and retrieve data to and from the database. Now, DBMS software and the database together, we additionally call it as a database system. Now, DBMS. DBMS is a software, as I said, allows to create, delete, or modify or manipulate data. Whatever you want to do with the data, we can do it with the help of the DBMS software. And apart from that, the DBMS software also provides security for your data, right? If at all we have a database and if you store the data in the database, and if I feel my data to be secure, I want my data to be secure and safe, then we go for the DBMS software, which provides us a security for our database. Database architecture, right? This is an important thing. Based on this only, how we are going to use our data, how the database is going to get structured, in which way we are going to store it, in which way we are going to retrieve it, how the data are going to get transferred. All these things are dependent totally on the architecture that we are going to use. Basically, there are three types of data types. Database DBMS architecture. That is, one is one-tier architecture, two-tier architecture, and three-tier architecture. Well, we have n-tier architecture as well. We'll go those in details. Now, to design a DBMS, that is totally dependent on the architecture of it. That can be either centralized, decentralized, or a hierarchical fashion, right? So, but whatever we do, the entire architecture, the entire DBMS structure is totally dependent on which architecture we are going to select, right? So this architecture, as I said already, can be divided into one tier, two tier, or three tier, and sometimes goes up to n-tier architecture, right? We'll be seeing all these things in detail, right? We'll be seeing about what is one-tier architecture, what is two-tier architecture, what is three-tier architecture, and how we go about n-tier architecture, all these things in detail in the forthcoming sessions. First, let us give a pictorial representation of this DBMS, right? So this DBMS architecture is the user is going to interact and give the application program, and then it's going to interact with the database to retrieve the data, or store the data, or manipulate or modify whatever I want to do. The user have to give information to the application program, and the application program in turn goes to the database and either retrieves or modifies or do whatever you want to the data to be done. Now, let us talk about single tier architecture. When I say single tier architecture, it means that your database and the DBMS is going to sit in one single system, right? So both the DBMS software and the database is going to be there in the single system, and whatever I want to do, I have to do it directly, right? So this is not given to the user directly, but probably it will be used by the developers and the database architects. Now, why should we go for this? And do we have any extensive tool for this, or do we have any user interface to work with it? If I say no, the reason is whatever we are going to do, we are going to do directly on the DBMS software. So whatever the user interface given by the DBMS software, we are going to use only that. We are not going to use any extensively separate thing. As I said already, the DBMS and the database is going to sit in the same system. Now, who uses it? Again, it's going to be the developer or the database architect who is going to work directly on the database, right? Whoever is going to work directly on the database and do some process in it and do modification or doing any creating an architecture of it, whatever we want to do, we can do it with the single tier architecture. Like, it is not going to cost you much. When we compare with the two tier and three tier architecture, the single tier architecture is very simple and cost effective, but one disadvantage is that we cannot give it to all the users, where they cannot go and do bigger work on it, right? So this is basically meant for the developers and the database architects. Now, as I said already, like, it doesn't provide any handy tools. You're going to use only the environment which is provided by the DBMS software that is given to us. Everything is going to be in a single system, right? So this is an architecture which I said, right? Whatever I'm going to do directly on the database on a DBMS software. So it can be It not only to be MySQL, it can be any of the DBMS softwares, right? So the database is going to sit on the DBMS. Right? DBMS and database both going to sit in the same system. So whatever process I'm going to do, I'm going to do it directly and I'm going to retrieve it directly, right? So this is not advisable for the end user. It is not advisable for a novice user. It is only advisable for the expert user. So this is all about single tier architecture. Now, when I say two-tier architecture, it is going to be having a client-server architecture-based kind of thing. It is not only one thing. It is a client-server. There are two sides that's going to be there. What is that? Let us see. Now, whenever I say it's a client-server architecture, right? So I have a client here and I have a server here. So it's going to interact with the database and it's going to retrieve the data. But in two-tier architecture, there are two types of two-tier architecture. Let us see that. First, it is, as I said already, in a client-server environment, the user interface is stored at the client machine, right? So the user interface, UI, is always at the client machine. There is no change in that, right? So whatever the user is going to use is going to be happening on the client machine, and the database is already always stored on the database server, right? So two things we understood: the user interface is going to be on the client side, and the database is going to be in the server side. No change in that. But what is going to get changed? Let us see that, right? So the data logic and the business logic, these are the two important things in your two-tier architecture, right? So this data logic and the business logic, where it is going to sit, either in the client side or the server side. That is what we are going to see, right? So if it is going to sit on the client side, we give it a different name. If it is going to sit on the server side, we are going to give it a, but both things need to get maintained properly, right? So three things I said, four things we have seen as of now. One is the user interface, database, and apart from that, the data logic and the business logic. This data logic and business logic is very, very important when we talk about two-tier architecture, and where it is going to sit, either on the client side or on the server side, depends on that. We are going to decide the architecture of it, right? So as I said already, there are two types of architecture when we compare, when we talk about two-tier architecture, right? Now, then my business logic and the data logic, right? When my business logic and data logic is going to sit on the client side, right? For example, if my business logic and the data logic, it is going to sit on the client side, then the heaviness of this is getting increased, correct? So the business logic and data logic is going to sit on the client side. The client is becoming bigger and it's heavier. Apart from user interface, these two things are going to come and sit. So if someone is bigger and if the person is hefty, what we call him? We call him fat person, right? Right? Obviously, we call him fat person. And if the person is very lean, we call him thin person or a fat or a thin person. The same way, here, your user interface, business logic, and data logic is going to sit on the client side. So we call it as fat client and thin server, because thin server has only database. Nothing to worry about it, right? Server has only database. We don't have anything else, right? So this type of client server architecture of two-tier architecture is called as fat client and thin server, right? Fat client and thin server. Now, if at all, my business logic and data logic is going to sit in my server side, right? So when I say server side, let me do it. Your business logic and your data logic is going to sit on my server side. Now my server is becoming fat, right? Now my server is becoming flat. So we call it as thin client, because client is very thin now, only user interface is there, and fat server. Thin client and fat server, right? So it depends on what the business requirement is. We go for either thin client fat server or fat client thin server. It depends purely on your requirement, and it depends on how the business requirement is, right? It is not that two-tier architecture means you need to go only for that, you need to go only for this. No, it is purely dependent on what you want, right? So this is advantage. That is, everything has its own advantage and disadvantages, right? We cannot say this is more advantageous than other thing, right? Obviously, one thing will be having an advantage over other, another thing will be having a disadvantage. Everything, both things are equivalent for everything, right? So everything will be having their own advantage and disadvantage. Don't try to find out which is the advantage and which is the disadvantage here as of now, right? So now, two-tier architecture, as I said already, right? Whenever I want to interact with this, I'll be using either a ODBC or a JDBC interface, right? The Open Database Connectivity or the Java Database Connectivity, right? So to connect with any of the database in client-server architecture, we'll be using ODBC, right? So this is in an example, I can say a library management, where a library will be having a client and you'll be having a user interface and you'll be storing the data and retrieving it back, right? So mostly like a normal small internal applications will be using two-tier architecture, right? So if at all a library management or a college management, school management systems, right, will be connecting over the network or the LAN and or sometimes like within the a network, a man or something like that, we'll be connecting over it, and then we'll be having a user interface on the client side, and the database will be having the on the server side, right? And again, your business logic or the data logic depends on what software you get. It may be either on the client side or on the server side, and also depends on the business requirement of your client, right? You cannot go and force your client, no, 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 this is right, that is right. It depends on your client and depends on the business requirement of them. You can go ahead and use accordingly, right? So this is the two-tier architecture that I was talking about, right? So let me go ahead about three-tier architecture, right? So now when I say clients, one-tier architecture, as I said already, everything is going to be in single system. And when I say two-tier architecture, it's going to be in two different places. One is your client, another one is your server. When I say three-tier architecture, now what is that these three tiers are going to have? Let us see that. So this three-tier schema is a extension of your two-tier architecture, right? So when I say three-tier architecture, it's an extension. Already we have a two-tier architecture, which is a client-server architecture. Now we are going to see three-tier, which is an extension of it, right? Now we have three layers in this. Three basic layers. When I say three-tier architecture, there are three layers. One is presentation layer, application layer, and the data server, right? Or the data layer, right? So presentation layer is your, it's going to be get stored inside your mobile or your tablet or your PC or your desktop, what you're going to use. Your presentation layer is going to be there on the end user side, right? And the application layer is going to be there on server side, and we have a database, right? So three things are there whenever I talk about three-tier architecture, right? That's the reason we call it as three-tier architecture. Three layers are there: presentation layer, application layer, and the data layer or the data server. So this DBMS architecture contains an application layer between the user and the DBMS, right? So when I have a DBMS, that's a software, right? That's a software. As of now, we were working directly on the DBMS software. Now we are getting introduced to something called as the application layer. Now, wherein that you will be getting an application where you can start typing, start working on it. So whatever you're going to fill in that, that's going to get given to that's going to be given, the information is going to get given to the DBMS, which is responsible for communicating with the user's request to the DBMS system. And then it sends the response from the DBMS to the user. So this application layer, the presentation, the user interface, it is going to be the single point of contact to the user. And the user is not going to directly interact with the DBMS or the database, I'm sorry, directly, whether he is going to use only the user interface, that is your application layer. So whatever he's going to see, whether he's going to provide the information or he's going to get the receive the information, everything is going to happen only on the user interface, right? So now the application layer, that is the business logic layer, also the process functional logic, the constraints and rules before passing data to the user or down to the database, right? So this is what is going to take care of everything to and from the database or the DBMS. So the presentation layer is going to give you all the information to the end user, right? The three-tier architecture is one of the most popular thing in your database management system. Now, any software, like for example, if at all I'm going to book a ticket, right? Your Make My Trip or your IRCTC website, right? Or any websites like where I'm going to fill my information in my user interface, right? So you're going to see only the user interface. The application layer is given to you. What is happening behind in the DBMS or what is going to store and get retrieved from the database, that is nothing required for you. The only point of contact for you is the application layer or the user interface. So whatever the user is going to use is the application program or the application layer. So this is going to get interacted with the application server, and then from there the application server like goes to the server and then interacts with the database, come back and provides the information. So it is a two-way communication where the presentation layer is accessed by the user, gives information to the DBMS, and the DBMS in turn interacts with the server that where the database is stored, and then gets and retrieves the data back from there, right? So to and fro database, the DBMS is going to play a middleman role where the application layer is used by the end user. Okay, this is all about your three-tier architecture, right? Now, what is the goal of this three-tier architecture? Like whenever we are using something, there should be some goal, right? Because why do we move from a two-tier architecture to a three-tier architecture with a lot of facilities inside that, right? So the three-tier architecture, as I said already, it's a client tier, that's the application layer, right? And the presentation, the application layer, the presentation layer, and the database server. So when I say application layer, that's going to be on the user side, right? The application layer, that's your DBMS, that it's going to interact with the database and the database server, right? Now let's go ahead. The goal of three-tier architecture is to separate the user application and the physical database. Now here in single-tier architecture, you have seen the person who is going to sit on the database and the DBMS and is going to work on the same system, right? But wherein in three-tier architecture, your application layer and the physical database is not together, it is separated in two different places, right? So for example, if I'm going to access any website, right? If I'm going to access any website like Make My Trip or IRCTC or Book My Show, right? These kind of things, like your application is going to be from your side, you're going to work on it. Your database is sitting somewhere, you don't even know where it is. And it is not required for you to know that. Okay, good. Now propose to support DBMS characteristics. What are the characteristics are there? It is going to get supported, right? And then program data independence. Program data independence. We can independently do a program without any interruption, right? Support of multi-views of data. That's very important, right? So these are the major goals of three-tier architecture. Now, when I say n-tier architecture, right? So this n-tier architecture is the wider angle of the three-tier architecture. It's an expansion of three-tier architecture where it is widely presented. For example, you go for a shopping cart, right? Your Amazon or a Flipkart or any website, like you want to access, like more people are going to access at the same time, and the data is getting distributed. Your data is not in one single page, right? Your data will get distributed, and your servers are in different countries. It's not in one single country. Your database are getting separated, and your network is getting wider and wider, right? Your cloud storage comes into play here. Your distributed network comes into play here. Whenever I say distributed network or distributed data getting stored, data is not getting stored in one place. Your data will get scattered and stored in different places, so that whenever I'm going to retrieve my data, the data retrieval will be much faster when we go for distributed network, right? So that is the major use of distributed network. We distribute the data and store it. When retrieving it, it is much faster when you compare with other thing, like you're in a single database server. Like if I'm going to store my data in a only single database in a single place, right? Retrieving the data but become much slower when compared with distributed data, right? So next we are going to see the commercial databases. There are different databases that are there. So let us see one by one what is what, right? So when I say commercial database, it means that you need to give some cost. It is not going to come for free, right? You have to pay some money and need to buy it. And they give something called as license, right? So this many license, 3 license, 4 license, 5 license, multi-user license, right? For 1 year, license for 1 year, a license for multiple years, license for lifetime, right? So these kind of things are there, but we need to give the money, pay, and get the database for a specific X amount of cost. And they will give you a license certificate that you can use it for these many days, or these many months, or these many years, or lifetime. It depends on the organization which you are providing it, right? So if at all I want my data to be safe, secure, and if my data is very important for me, better we need to go for the commercial database. That's going to give you support. They're going to give you support, not only support, apart from that, they're going to give the safe and secure security, and they are going to give you assurance that the data will be secure, right? So this will be definitely costlier when we buy it, right? So now examples of databases, right? Oracle, right? They are the pioneers, right? If anyone says a database, people will close their eyes and say Oracle. They're the pioneers of it. They started, and they are the they were almost an omnipresent before, but now a lot of players came in. But when you say database, people close their eyes and go and they buy Oracle, right? It's very costly, right? and they started their marketing their product in 1970s. These are just 79s, and these are just histories about it, right? Now, Microsoft SQL Server, right? Everyone, like, you know that Microsoft is a will try to compete with everything that comes in the market, right? Because they're the big player in they are the very big player in the market, right? So now this Microsoft SQL Server came into existence, right? So to just show that they also can do database, right? When we compare with Oracle and Microsoft SQL Server, but like people prefer Oracle over Microsoft SQL Server. Amazon Simple DB, and we have other things that is Teradata, IBM DB2, Informix, SAP, right? And apart from that, now people are going towards MongoDB, right? Which is not a commercial database. We don't need to buy anything, right? They are giving free of cost, and they are also, right? They also give free training. Everything is free, right? People are getting right educated because of this, right? Anyway, they don't use SQL. They are something different, right? They are not an RDBMS. The reason I have not mentioned here, because they are not they don't use, it's not an RDBMS. It is a NoSQL database, right? So anyway, right, that's not our syllabus, so I'm not going to talk about it, right? Good. The DBMS models. As of now, I'm talking only about DBMS. I'm yet to go into RDBMS, right? So there are different types of DBMS. Before the RDBMS was found, there were people using DBMS only. What are the different models of DBMS? That is what we're going to see now. Now, database models defines a logical design and structure of the database, right? And defines how data will be stored, right? If at all I want to say, this is how my data is getting stored, this database model is very important, right? I cannot say how your data is stored. I don't know. The data is getting stored. How it is getting stored, that's very important. What is the architecture of it? What we are going to see? What is the architecture that we have used in this? So everything is getting important when we talk about database models, right? How we are going to store the data, how we are going to retrieve the data, how my data is getting related. All these things are very important, right? So while the relational model is the widely used database model, as of now, the widely used is the relational model that we are going to talk in few minutes, right? But apart from this, we had the older database DBMS models, that is a flat file system, hierarchical model, and the network model, right? So these are the three models that we have used before RDBMS came into existence. That is your flat file system, hierarchical model, and network model. Let us see one by one. So when I say flat file system, right? So files, right? My data is getting stored inside the file, right? As a normal file, right? A notepad kind of thing, or a wordpad kind of thing, or any data that I'll be using, and I'll be using a programming language, right? So people those who have already know about C++, all these things, we use files, right? So files, we store the data inside the file. We use a text file to store the data, right? So and the data need to get stored inside the file. Yes, it can stored in the file as a flat file system. But what are the disadvantages there? More disadvantages are there. But one advantage is that before we were writing on a ledger, like we'll be having notes, books, and writing in it. And when flat file system came into existence, most of the programming languages start using it so that they feel easy rather than writing on notes, right? So now it's a first attempt, right? Flat file system, as I said, it's a first attempt to computerize your data, right? Before, like as I said, we were taking note, writing, paper, pen, all these kind of work, right? So those kind of work has been sidelined, and we started using the computerized data storage method. That's first is your flat file system. The retrieval of data was possible only by the sequential reading, right? For example, if I want to read this line of data, right? And if I use a programming language, not manually, if you want to manually, you can ask me, like I can go manually read it. No, it's not about manual reading. It is all about reading the data through computerized, through programming language, right? Through any programming language like C, C++, or Java, anything, right? If I want to store my data manually, right, it'll be very difficult to do it. But if I use a flat file system, I use a programming language and then store it. Yes. After storing it, if I want to retrieve my data, my program only start reading from the first line. It'll read the line. Whether my data is there, no. Read the second line, no. Read the third line. Like this, every line will be read till it comes here. So your data, if at all I want to read it, I have to read only in a sequential manner. And updating, deleting, my goodness, it is almost impossible. It is possible, but why I said almost impossible? Because if I want to do something to this line, right? I've read this line, I want to make some change here, or to change the name of the person. You have to read everything from this place to this place, store it in a new file. All these lines, store it in a new file, right? Store it in a new file, and then after storing these lines in a new file, neglect this line. Whatever change you want to make it here in the new file, and from here till the end, read it again, store it inside the new file. So this is the bigger process. This is a very big process. Small change required, you're gone. Right? And one more problem is there. The only way to delete it, as I said, creating a new record, take everything, put it here, remove that line, put the remaining things later. That's how we do it, right? And if at all I may store some data repeatedly, then you will be in trouble, right? So if I'm having some data here, by mistake, I can also store the data again in the next slide. So redundancy is unavoidable, right? Because you don't have any checking facility to stop and say whether it is there or not. No, you don't have any checking facility to do that. Data redundancy is another problem here. The only way to update record, as I said already, you need to read sequentially, go to record by record, and then change it, right? So these are the problems that we face. This is how we do it. And what are the problems that we are going to do? Data redundancy, as I said already, it is a major problem in flat file system, right? So you may repeat the data unknowingly. It is not by knowingly, but by unknowingly, you may repeat the data again and again. Next, poor data control, right? So as I said already, you have poor data control. What is there inside, which is there, which is not there, whether it is there or not, you don't have any control over it. Next, inability to easily manipulate data. As I said already, you cannot manipulate the data. You have to go line by line, take the data, store it in a different file, modify it, put it in a different file. No, that's a bigger process. It's not going to happen directly. Cryptic workflow. Accessing the data could take excessive programming effort. You have to be a very good programmer to do the work, or else you go mad. Okay. So this is all about the flat file system, and these are the disadvantages of flat file system. Yes, there are advantages when we compare with the ledger system. Next is the hierarchical model. This is one of the important model in DBMS system. Now, when I say hierarchical model, it's going to be in a hierarchical fashion. That's going to be like a parent-child relationship kind of thing, right? So you have a root node or a parent node, and then child nodes like this. Now here the database model organizes in a tree-like structure. You can see it is like a tree-like structure, and there's a single root here. Now here the college is the root. Anything and everything has to be done only with the knowledge of this root. Without the knowledge of root, you cannot modify any data. Fine. The hierarchical always starts from the root. Yes, that is the only option we have. And expand is like a tree and adding child nodes again and again. But if I want to do something here, right? If I want to add something here, what should I do? I cannot go directly to this place. What I need to do? From the root, come one by one and then only do it. Right? That's the only option we have to do it, right? In this model, a child node will only have one single parent, right? It means that the child here theory have only one single parent, that is course, which cannot get related to the another thing, that is another parent. It's not possible at all. One child, only one parent is possible in hierarchical model. And more efficiently describing many real world relationship, right? Yeah, that is very good, right? Whenever I want to have some real world explanation, right, real world kind of thing, yes, this is one of the good model that we can give some real time explanation about the database, right? Now hierarchical model data is organized, like as I said, as a tree like structure with one to many relationship, right? One to many relationship. Two different data types are, like for example, when I say department, I can have course, teacher and student. So it is a one-way communication. Department can have course, teacher and student. I cannot go this way, right? So two-way communication is not possible. It's just a one-way communication and just a one-to-many communication, right? So from course, I cannot go back to department and do it. So whenever there's a hierarchical model, hierarchical fashion of data need to be stored, then only we can go for a hierarchical model. In a normal database environment, definitely we cannot go for this. There's a bigger problem when we go with that. Right. Now let us see what are the disadvantages of hierarchical database model. One, accessing child node only through parent. There is no other way, as I said already, right? That's the only way. And child record cannot be inserted without a parent, right? If I want to say something, no, only without the knowledge of a parent, without the knowledge of the root, I cannot insert anything in between. One child record can have only one parent, also they said like I cannot have multiple access to it. Here we don't have any querying facility, right, where I can go retrieve data. No, I have to start from the beginning and then do it only in the hierarchical fashion. No referential and constraint concept here. No constraint concept here, nothing, right? You have like this constraint, you have to give only this kind of data. You cannot give any constraint here. That's not possible, right? Redundancy of data obviously will be there. We cannot avoid it. And then very cryptic macro. These are the bigger disadvantages of hierarchical database model. Now, next is the network model. So this network model is like a tree-like structure again, but we can have like more than one parent for this, right? In this is solving the purpose of your hierarchical model. Hierarchical model has a disadvantage. What is that? One child, one parent. But here I have a child for a C2 which has two parents, B1 and B2. So one one data can retrieve information from more than one data. Now this is an extension, as I said already, of an hierarchical model. In this model, data is organized like more like a graph and are allowed to have more than one parent. That is the advantage over your hierarchical model. So in this datable model is a more related as more relationship or established more relationships, not only one single relationship, can have more relationship datable model. And also a data is more related. Hence, accessing the data is also easier and faster. When I say in a hierarchical model, I have to come step by step and then do it, right? So to reach C2, I have two ways, right? Either I can come A to B1 and B1 to C2, or I can come to A to B2 and B2 to C2. So these are two ways that I can access C2. Whichever is possible way, whichever is the shortest way, I'll be using it, right? Good. Next, there are most widely used database models, that is relational model that was introduced, right? After this hierarchical model only, the relational model is getting introduced. That is the most important model that has been followed till date. Now, the disadvantages of relational network model: one, difficult to access the system using cumbersome pointer concept. Yes, very difficult. When we go for cumbersome pointer concept, that becomes very, very difficult because that's a problem here, right? And it was useful for the programmer that real users, right? Real users, no, the real users will get confused out of this because only the programmer can understand it properly, right? So these are the major disadvantages of your network model. Next is the relational database model, or the RDBMS, relational database management system, or the relational database model that we are going to see now, right? So now this is developed by Dr. E.F. Cord at IBM in the early 70s, who was looking for ways to solve the problems with the existing model. What are the problems in existing model? We have seen a lot of problems in existing models, like hierarchical fashion, right? Only one parent, and then like solve the problem of one parent, and again like only the developers can use it, no one can use it. All these problems are there. So this RDBMS resolved all the problems, and then Dr. E.F. Cord has developed this relational database management system, that is your RDBMS. Now it is mostly based on the mathematical model or the relational algebra. Now at the core of the relational model is the concept of tables. Now what we are going to see here is tables, which has rows and columns. Your data are structured properly with some structure. What is that? A row column structure, a table structure, right? So we are going to, something new is getting introduced. Now, till now, we don't have that kind of structure. We have a lot of structures like hierarchical, network, tree kind of structure, graph kind of structure, flat file system, all these things we have seen. But first time we are seeing to a table format of structure, where your data is going to get stored there only, right? So each table is made up of records, that is horizontal rows, or known as tuples, and and fields, right? Horizontal records are fields, and vertical columns are known as attributes, right? So now we have some data there that we call it as a tuple or attributes. We'll see those things in detail. Now, data is separated from application, no more application dependent or centric, right? So it's going to be a separate application and a separate data. It's getting separated. So this is how your RDBMS model looks like, right? So we have some data stored here. That is your student ID, name and age. Here your student ID, name and teacher, right? So now you have these kind of structure in that, and then we'll be seeing those things in detail now. This is how your data is getting stored in relational database management system. Now, ER diagram, right? So ER diagram helps me in understanding, right, how your relational database is, right? So entity relationship model, right, is a pictorial or a graphical representation of the structure, right? How I'm going to relate the data. So it's going to give me a graphical representation of it, right? Now here, I say ERD or entity relationship diagram, right? So now we have various symbols to represent it, right? So when we say table, it's called as entity, a row is called as a tuple, and column is called as attribute. So these three things are very important that we need to understand, right? So table is the entity, row, every row is called as tuple, and every column is called as attribute, right? Good. The components of ER diagram. Now, these are the components of ER diagram. When I say entity, that is represented in the format of triangle, and attribute is represented in the form of oval, and relationship is represented in the format of diamond, right? Now, here we have something called as weak entity, multi-valid attribute, and weak relationship that we'll see this in detail, right? Now, what is entity? Now, in a relational database, an entity is a single person, place, or a thing, or whatever we are going to say. For example, employee, student, person, all these things are called as entity, right? So they are going to have some attributes that we'll see that in detail, right? So these entities are usually recognizable concept, either concrete or abstract, such as person, place, thing, or event, which has relevant to the database, right? So as I said already, employee, person, student, right? Account holder, customer, all these are entities, we call them. Now, some special features of entities are, as I said already, that's not why I was explaining about that. Now, the student is an entity. What is student? It is an entity, right? Okay. So student here is an entity. Now here these things are your information which is stored inside the entity student. Next we are going to see attribute. A database is simply a column in a table, right? Database attribute. When I say attribute, it is a column, right? Here I say student ID. Student ID is an attribute. Student name is an attribute. Address is an attribute. Age is an attribute. Gender is an attribute. Semester is an attribute. So these informations, what I am giving, all these things are called as attributes. Now, entity is a customer. What are the attributes here? Customer ID, first name, surname, last name, date of birth, phone number. All these things will become your attributes. Now, here in this example, what are your attributes? Student ID, student name, address, age, gender, and example. These are your attributes. Okay. Now, relationship. When I relate two tables, right? What kind of relationship I'm going to relate? That's called as relationship. Now here, the association between instance of one or more entity, right? I have an entity, one more entity. If I'm going to relate these two things together, they are called as relationship. Now, meaningful association among several entities. It's not about like just like that adding. I have to give a meaningful entity for it, right? So let me give that. Author writes book. Now this author is an entity, book is an entity. How they are getting related? Author is going to write book. So the relationship between them is that the rights. Author writes books. One entity, another entity. Getting related with a diamond symbol that we call it as rights. The types of relationship, right? If I want to have relationship between one table, another table, there are three types of relationships, right? That we'll see one by one. There is one-to-one relationship, one-to-many relationship, and many-to-many relationship, right? So when an individual data is getting related with another individual data, or one data is getting related with multiple data, these are called as one-to-one, one-to-many, or many-to-many relationship, right? So Why do we go for relationship? Because we are going to divide our tables into multiple tables, and finally we relate them together, right? So we divide the tables and relate them together so that we require a relationship, and it can be either a one-to-one or a one-to-many or many-to-many relationship, as I said already, right? So when I say one-to-one relationship, it means that one single record, it is getting related to another single record in another table, right? So this is one entity, the entity name is employee, and we have one more entity that is called as compensation. So this entity and this entity is getting related, right? Here you can see the employee ID is getting matched with another employee ID here. This is a one-to-one relationship, right? So one entry there is getting related to another entry here. This type of relationship is called as one-to-one relationship, right? So when I say one-to-many relationship, when one entity, or sorry, one tuple or one entry, right, it is getting related to more than one here. So when I say 9003 is an entity, right, so is a tuple here, right, an entry or a tuple which is getting related with many values here. So 9003, 9003, 9003, three times here it is getting related. So this kind of relationship is called as one-to-many relationship. So one row related to more than one row in another table. So this kind of relationship is called as one-to-many relationship. Next is the many-to-many relationship. When more than one data related to more than one data on the other table, and vice versa, one data is getting related with more than one data here. This kind of relationship is called as many-to-many relationship. Okay, so we have seen three types of relationship, that is one-to-one, one-to-many, and many-to-many relationship. Next, we are going to see cardinality and ordinality, right? So when I say cardinality and ordinality, it is all about how we relate, right? We have seen one-to-one, one-to-many, many-to-many relationship, right? So how we relate our data with the cardinality and ordinality, right? So we have few types here, that is, if this is there, if only one line is there, then it means one. If many lines are there, it is called as many, right? Now here I can say one and only one, zero or one or many, zero or many, right? Now here what I'm mentioning here, the maximum relationship that it can have, that is called as cardinality, right? So the maximum instance that it can relate to, right? So whenever I have say one from here relating to more than one, when I say more than one or one, what is the maximum here? For example, here we can see in this relationship, the maximum is one, correct? The minimum is one. The minimum here is one, and the maximum is one. Here the minimum is zero, and the maximum is one. Here minimum is one, and maximum is many, right? So this is minimum is zero, maximum is one, minimum is one, maximum is one. Here the minimum is zero and the maximum is many, right? Now when I say zero, minimum or the maximum values, what I've given here, here the maximum is one, maximum is one, maximum is many, maximum is many. The maximum what I'm mentioning here is called as a cardinality, and the minimum what I have here is called as the ordinality. Okay, let me read this for you. Cardinality refers to the maximum number of times. I'll repeat, maximum number of times an instance in one entity can be related to the instance of another entity. So maximum, what is that it can relate? One. What is the maximum that it can have? One. What is the maximum that it can have here? One. So this kind of relationship, mentioning these things, is called as cardinality. And what is ordinality? It is the minimum number of times an instance in one entity can be associated. So when I say from here, one is getting related to more than one here, or it can be zero also. So the zero is the ordinality here. The one is the ordinality here, and zero is the ordinality here. So cardinality means what is the maximum relationship that it can have, and ordinality means what is the minimum relationship that it can have, right? So it can be from 0 to 1 means your ordinality is 0, cardinality is many, right? So when I say 1 to 1, right, maximum 1, minimum 1, then your ordinality is 1 and cardinality is 1. So it depends on how you require it and how you use it, right? So cardinality, ordinality are shown here. You can see that. Okay. So here I've mentioned everything, right? So let me give an example. Now here I say customer. What is the cardinality of customer? Cardinality is 1, right? And what is the ordinality? That is also 1. Now here, what is the ordinality? That is 0. What is the cardinality? 1. So it means that minimum one customer can have minimum 0 or 1 account. You with me? So I am saying about the minimum. Minimum one customer can have minimum 0 or maximum 1 account, not more than that. Right? That is what it means. It is a one-to-one relationship. What kind of relationship is that? One-to-one relationship. Okay. Now here I have a one-to-many relationship. In this, one advisor can advise one student or more than one student. I'll repeat, one advisor can advise one or more student. So it is a one-to-many relationship. Now, what is the cardinality here? Cardinality is many. What is the ordinality here? One. Okay, next. That is many to many. Here I can say many courses, great terms for a student, many student, or zero or many student, right? So I can say zero or many student can take zero or more courses, right? So some students can take, no, I will not take any course. This is not required for me. I'll sit idle. Let them sit idle. So it means that zero or more students can have zero or more courses. So these are the examples for cardinality and ordinality. Now, what are the disadvantages of RDBMS? When I say RDBMS, there should be, as of now, we have seen what is RDBMS and how it works, all those things. What are the advantages of RDBMS? One, increase the sharing of data and faster development of new application. So whenever I want to develop some application faster and transferring the data, RDBMS is one of the best thing to do it. And next, supports a simple data structure, namely tables and relations. It's very simple. We give it in the form of tables and relations. Next, it limits redundancy or replication of data, right? Whenever I feel that my data is getting replicated, my data is getting redundant, then I can go for RDBMS. Okay. Then what is another advantage? Better integrity as data inconsistency avoided, right? So very important thing is the data inconsistency, right? Many things we have seen in other database and DBMS model that we have a lot of data inconsistency, but here data inconsistency is avoided by storing data in only one place. Simple, right? In database. Now expandability is relatively easy, right? So whenever I want to expand something, whenever I want to add something, when we seen in file system, no, not possible at all. When we seen in hierarchical model, yes, possible with a lot of constraints. When we see in network model, yes, lot of confusions, right? So, but here when I say RDBMS, expandability is easy, very, very easy when compared with other DBMS models. Better backup and recovery. That's very important, right? We can back up our data and retrieve our data easily and as per our requirement. Next, provides multiple interface, right? Here RDBMS provides you multiple interface to do it. Next, solves many problems created by the database models. Whatever we have seen in those models, all the problems are solved here. Ability to handle efficiently simple data types. So whatever data types is very important, right? So data types is one advantage that is there in your RDBMS, right? What kind of data I'm going to store? Whether I'm going to store a number, yes, you have a data type number. If I'm going to store a character, you have a data type character. If I'm going to store date, yes, you have a data type for date. So for everything, we have a data type to store as per our requirement. So multiple user can access. Very, very important that multiple access is possible in RDBMS where it is not at all possible in DBMS, right? Now, when there's an advantage, there will be some disadvantage. What are those? Required skill, knowledge to implement. That's very important. You should have knowledge. Without knowledge, you cannot do anything. Certain applications are slower processing. It depends on which RDBMS you use, right? There are a lot of RDBMSs there, and certain applications are, yes, slower and increases vulnerability. Increased vulnerability. So you said like, yes, definitely I said, but there are disadvantages as well, right? And most difficult to recover the data is lost. We can restore, we can store the data, we can back up it, and we can retrieve it. But once the data is lost, it's very difficult to retrieve. I'm not talking about the data backup and retrieving, but the data backup itself gone. Where will you go? It's very difficult to retrieve the lost data, right? Seen as poor representation of the real world, right? Real-time world, like when we say like about RDBMS, it is not as much as good when we go for RDBMS. Real-time representation is not there, but they have their own advantage as well. Okay. Now, difficult to represent hierarchies, not at all possible, right? So when I say hierarchical, we have to go for hierarchical model, but it has its own hell a lot of disadvantages. But we have come across everything and we come to relational database management system. Definitely, it is very difficult to represent hierarchical and difficult to represent complex data types. Yes, there are data types, but when it comes for complex data types, then it will be more complex. Okay, fine. So next we'll see normalization. Normalization. So when I say normalization, this is one of the important concept in relational database management system, that is your RDBMS. Now this normalization plays a major role in RDBMS, right? Whenever we face some problems, as we've seen in DBMS, we face a lot of problems, right? The data is getting redundant, like repetition of data, right? Data is not formulated properly, not structured properly. A lot of problems are there in DBMS, but this normalization helps you in overcoming a lot of disadvantages that we face. The main thing is that normalization helps me in dividing the tables, right? So it allows me to avoid the redundancy by dividing the tables, right? So whenever we feel the data is getting repeated, right? Whenever there is a redundant data, it helps us to divide the data, avoid redundancy, right? That's a major use of normalization. Next is that, right, it involves in restructuring the table, right? When I divide, I may need to again restructure the table. For example, if I have a table of 6 columns and I feel some data is getting repeated again and again, I want to avoid redundancy. What I'll do, I will be dividing the table into 2 or 3, and after that, I'll be restructuring the table, 3 tables, right? I'll be restructuring the 3 tables and give some constraints to it, right? So this normalization helps me in restructuring, not only dividing, not only avoiding the redundancy, it also helps me in restructuring the table, right? So there are a few characteristics that need to be followed when we think that we need to go for normalization, right? So these are the things. One, scalar values in each field. For example, if I have a column and I have only one field in that column, it can have only one value at a time. We cannot have more than one value in single field. That's one important feature of the normalization. Next, absence of redundancy. If I feel my data is getting repeated again and again, yes, it allows me, it helps me in avoiding the redundancy, right? So when I say my table is normalized, one thing, there should be some scalar values, there is only one value in each field, and absence of redundancy. Next is minimal use of null values. I cannot keep on putting null everywhere, right? So I should have some valid values everywhere. And one important thing is that there should be very minimal null values. Some places, yes, we may have to fill null, but not all. Not in all places we are going to give null. And next, minimal loss of information. Sometimes when we divide the tables, there are a lot of chances that we may miss or lose data. So this can be this loss of data have to be taken care when we go for normalization. 4 things, important things: only scalar values in each field. Next, absence of redundancy. 3, minimal use of null values, minimal loss of information. Yes, obviously sometime we may lose data, but we may need to make sure that we are losing only few data, right? Not all. Okay, good. So let us go for the levels of normalization. What are the levels of normalization? So we go for the levels of different levels of normalization based on the redundant data, right? If I'm going to have some redundant data, right, depends upon the redundancy, depends upon like how my data is getting stored, right? How I'm going to divide my data, I'll be going for normalization, right? Now, various levels of normalization. One is first normal form, second normal form, third normal form, BCNF, fourth normal form, fifth normal form, and DKNF. These are the normalizations that are available. 7 steps or 7 levels of normalization, right? So in each and every normal form, we'll be fine tuning, we'll be restructuring our already existing tables in the database. Okay, let us see those things, all these normalization in detail one by one. First normal form. Now, what is this first normal form? What is it we are going to see in this first normal form? So the table is considered to be in first normal form if all fields have only scalar values. When I say scalar values, it means that my values are not going to get repeated. Only sorry, not going to have more than one value in a field. Only one value is allowed. More than one value is not allowed. If it is there, then it is not in first normal form. If at all a table is said to be in first normal form, only if I have scalar value in each field. Okay, next, let me give an example for it. Now here in this table, we can see we have some values which is present inside. This is a table. There's a table which is not normalized. A table, an unnormalized table, right? A raw table which is there for me. If at all I want to do some process to it, if at all I want to apply normalization to it, what and all I have to do? First, I need to check whether it is in first normal form. Then only I go to the next level, right? So it is like a hierarchy. First norm, it should be in first normal, and then I will go for second normalization. If my table should be in second normal form, it has to satisfy first normal form as well. If my table has to be in third normal form, it has to satisfy first normal form, second normal form, and then only I can give third normalization, right? So here it is like a hierarchy. If I want my table to be in third normal form, definitely it is must that it should be in your first and second normal form. If at all I want to say that I want my table to be fifth normal form, then it should be 1, 2, 3, and 4, like that, right? So it is a hierarchy that we need to follow. Now here you can see this my ISBN. I have only one value, no problem. Everywhere I have only one value, so no problem at all, right? And title, I have one. Here also one, here also one, here also one, right? Visual basic is a one single thing, since there is no space, right? It is coming in the second line, right? Okay, now here this ISBN, no problem, perfect, checked. Title, checked, no problem, right? And I come to author name. Now here I say author name have Sleepy, Snoopy, and Gumpy. Three author names for a single book. Obviously, right? And sometimes, right, we may have three author names or four authors together authoring a book. We cannot say that no, one book, only one author, because I have to have scalar values. No, it's not like that. I can divide it. Yes, obviously I can divide it. That is what we're going to see how to do it first normal form. So the problem here is that I have more than one value in this field. Here I have Jones and Smith authoring the book Main Street. I have more than one value. There is two values. Now here this or no problem, right? So in author name, I have to make some changes because it doesn't have any scalar values. Now, when I say author phone, so you cannot say that one person holds only one phone number. No, I have two phone numbers. Another person will be having three phone numbers. You cannot stop them. And moreover, like here we have three authors. They will be having everyone at least having one phone number, and they will be. You cannot say that only one phone number for the entire book who's authoring. No. So this first phone number is for Sleepy, second phone number is for Snoopy, and third phone number is for the Gumpy. Right? You cannot say that you can have only one phone number. That is not at all possible. And the publisher name is Small House, no problem. So here you have a problem. This cannot happen. Here you have two authors and you have two phone numbers, each representing one of them. Now this is also not possible in first normal form, right? So everywhere you can see, whenever you don't have a scalar value, that is, you don't have single value in a field, then it is not said to be in first normal form. Then you are in trouble. What should I do? The next step, I need to perform the first normalization on it, and then I need to start decomposing the table. How will I do it? That is what I'm going to teach you now. I hope you understood these things, right? I'll repeat, whenever I have more than one value in a field, then it is not said to be in first normal form. We may need to divide our tables to make it available in first normal form. Okay, so let us decompose things. That the decomposition means dividing and then creating new table, right? So let us see how it is doing, right? So designating primary key values. Now let me explain you what is primary key in the next forthcoming session. I'll explain you what is the key constraints shortly, right? When I say normalization is there, right? So I'm dividing the table, right? I'm dividing the table into two. How was the table before? The table has ISBN, title, publisher name, phone number, author name, everything, right? Author, phone number, everything was there. Now what I'm doing is that I'm dividing it, right? I'm dividing it, right? So I'm just dividing the table into two, right? I'm dividing the table into two, and here you can see, right? I have title, phone number, publisher, phone number, because publisher is going to have only phone number, only one phone number and the price for it, no problem. But when I say author, right, it has Sleepy is there, Snoopy is there, Gumpy is there, Jones, Smith, Thomas. Now here in the previous example, right, before normalization, it was like 1, 2, 3, 4. Only four rows are there. But we have more than one data in each. So that's the reason we are dividing it. So when I divide, I'm going to take ISBN, title, publisher name, publisher phone number, and price. I'm going to take this out. Why I'm taking this out? These are the two columns which is having more than one value in a field. It means that it is not a scalar value. So I'm going to pull this out. I'm going to pull these two columns out. But apart from that, ISBN, title, publisher name, publisher phone number, price, no problem at all. Everything is having scalar values. Now I'm just keeping it as it is, right? I'm just keeping that as it is. ISBN, title, publisher name, phone number, and price. And then I'm dividing, as I said, I've divided author name and author phone, right? Okay, why I require this ISBN here? Because this ISBN is the one which is going to relate your first table and the second table. The reason why should I relate my first table and second table? Because if I don't relate, this becomes two different tables. But from one single table, I'm dividing two, then there should be a relationship. When I don't have place, I'll divide and keep those two things, and then I should have a proper relationship. If I don't have a proper relationship between the first table and the second table, then I will be in trouble. Okay, now here ISBN is your column which is going to identify the entire row. So whenever a column is identifying the entire table, right, every value in that column is identifying the entire right, tuple of it, right? So now here the first tuple is identified with the help of ISBN, that is balloon, small house, and then now here who has written this book balloon, and the publisher is publishing, no problem, everything, but who has written, who is the author? So I can identify this with the help of ISBN number. Now here the ISBN number is 321-321-32-1. Now I will go and search this ISBN number here. It is there. Okay, good. It is here. I can found it, right? Who has written this? Sleepy. Is there any more relationship? Yes, I have one more here, Snoopy. I have one more here, that is Gumpy. Now here, what kind of relationship that I'm having? One, and here we have three. So this relationship, what we have here is one to many. One to many. Right? So what relationship that we have here is a one to many relationship, right? Now here one ID is identifying three rows here in the next table, a one to many relationship. You're with me, guys? Yes. Now this is how I identify it. Now after identifying it, as I say, I'm dividing the thing and then putting it separately, my author name and phone number. If at all I don't have an ISBN number, then I'll be in trouble because I cannot relate my first table and the second table. Anytime you divide a table into two or three, all these three tables must get related to each other. If at all it is not getting related to each other, then we cannot say that it is a properly normalized table. Good. So let us go ahead. The important thing, as we have seen in the previous thing, we are saying designate a primary key for each table. Let me tell you what is primary key. A row or a column and its value, which is identifying the entire tuple, right? Now here, this ISBN number is the one which is identifying this entire tuple. Now here, this is the one which is identifying the entire tuple. When I say a key is a column is a primary key, then that must be having some constraint, right? So let us see that in detail. Right now, I'm going to tell you what is primary key and other things, right? Now here, the constraints, right? We are going to set a constraint for every column, right? One column, if I want to give some constraint, I can do that. If I want to set some constraint for the entire table, right? I have to give only for the columns, not for the table, right? If I'm going to give a constraint, yes, this column have some constraint. This column have some constraint. I cannot say the entire table, this constraint. No, for every column, I need to say what is my constraint, right? And it is not necessary that every column must have a constraint. Depends on your requirement. You can have a constraint or you can not have a constraint, right? So first constraint, what we are going to see is primary key. Now, primary key, as I said already, it uniquely identifies a row or a record in a database table. So here, previously I've said that ISBN number is the primary key, which is identifying the entire record in a table, right? And that will be unique. That will be not null. Two things are there for that. It will be unique and it will be not null. Any primary key, any column is said to be primary key. If I say this ISBN number is a having a constraint called as primary key constraint, when I say this is my primary key constraint, now this entire column, right? Entire column is said to be a primary key, and two constraints are there. One, it should be not null, right? It should be not null, and I cannot have any repetitions. Unique, it must be unique and it must be not null, right? Two things are there for a primary key. One, I repeat, the data must be unique and you cannot have any null values. Then that column you can set it as a primary key, or else you cannot give a constraint as primary key there. Okay, let us see. First one, as I said already, it uniquely identifies a row, right? And it cannot have any null values. Foreign key uniquely identifies a row or record in any given table, right? So now what it does, how it identifies it, right? Now in another table, not in the given table, right? Of any given table, how will it work, right? Now here you can see in this example, now here this ISBN is your foreign key. This ISBN is your foreign key. Why do I say this as a foreign key? Because it is going to identify your element which is there in another table, right? If I want to relate this table to this table, I must have a foreign key. How will I choose a foreign key? If I have a primary key in that table, mostly that column will be foreign key another table so that I can relate it, right? So this ISBN here in this table, right? So for example, if this table is a publisher table, right? If I say this table name is publisher, right? This table name is publisher, and then this table as author, right? Now when I name this as author, now for author, ISBN is my foreign key, and for publisher, ISBN is my primary key, because this foreign key is going to relate to my parent table with the help of a relationship constraint, right? What is that? Primary key and the foreign key. That's how it gets related, or else I cannot relate my table, right? And that's your foreign key. Now, unique. If at all I want my values to be unique, for example, phone number. There is a column called as phone number in the previous example. When I say phone number, you cannot make a phone number to be appear for more than one person. My phone number is unique to me. Another person cannot have it. For example, email address of a person. There cannot be a same repeated unique email ID for anyone. Not possible at all. So if at all I say unique, it is unique. As the name suggests, it is unique. We cannot have same names for all the values in the column, right? So that is your unique. And not null, if I say there must be some data, for example, author name, I cannot say there is no author for the book. There must be an author for the book. And I cannot say there's no publisher for this book. No, it's not possible. There must be a publisher for that book. So your publisher name, your author name, all these things must be a not null. It not necessarily that I need to give not null everywhere. Depends on the scenario, depends on the example what you're giving, depends on the scenario what you're taking. You can have that column as a null or a not null, depends on you, right? And next is default. For example, if I want to give some default value for the entire column, whoever comes in, right? I know that that is a default for me. I can go and give a default value. For example, I'm running an organization in Chennai, and I say that people only from Chennai are allowed in this organization. Now, if I go to have a column as location, by default, it's going to be Chennai. So I can say set my column as Chennai by default. I don't have to give the values often. Okay, good. So these are the constraints that we are going to see. And finally, there is check constraint, right? If at all I want to ensure that column satisfies certain condition, then only store the value, right? Don't store all the values. So I can go for check constraint. So these are the constraints that we have: primary key, foreign key, unique, not null, default, and check. These are the six major constraints that we use in any RDBMS. Fine. So let us go to the next one. Next important thing is functional dependency. Now let us see what is functional dependency. So if one is set to like if at all one set of attribute, for example, attribute means one column, one set of attribute in the table determines another set of attribute in the table. For example, one column is dependent on the another column. Then the second set of attribute is said to be functionally dependent on the first set of the attribute, right? Here I say the author name, right, and the phone number. The author phone number is dependent on author name or vice versa, right? This kind of relationship is called as functional dependency. If one column is dependent on another column, then it is called as functional dependency. As I said already, author name, phone number, right? Author ID and author name, ISBN number and the book name. So this kind of relationship is called as functional dependency. One column is fully dependent on another column is called as functional dependency. Now, let me give an example. Now here in this example, I'm taking the same example. I have ISBN number, title and the price. Now here I say that I have three columns, ISBN, title and price. Now here, what are the functional dependency? ISBN title is dependent on ISBN number and price is also dependent on ISBN number. So this kind of relationship is called as functional dependency. So let me give you one more example. Here, as I said already, title is dependent on ISBN and price is also dependent on ISBN, right? So this kind of dependency that I can say title is functionally dependent on ISBN and price is functionally dependent on ISBN. So another example let me give you, right? Here I have publisher ID, publisher name and publisher phone number. Now here you can see that the publisher phone number is dependent on publisher ID and publisher name is dependent on publisher ID. And I can say that both publisher phone number and publisher name are functionally dependent on publisher ID. Now here, this is fully dependent, functionally dependent on that particular column. Let me give you one more example. Here I have author ID, author name, and author phone. Now here, what is it? I can say author name is functionally dependent on author ID, and author phone number is functionally dependent on author ID again. So here, on the whole, I can say author name and author ID, right? Both are functionally dependent on one column, that is your author ID, right? So here it is dependent on author ID. Both the columns are dependent on author ID. As the same way here, publisher name and publisher phone number both are functionally dependent on publisher ID. Okay, fine. So now let us go to second normal form. So when I say second normal form, right, one important thing is that if at all any table that I want to make it as second normal form, one important thing is that it must be in first normal form, right? So that is the first criteria that need to follow. So what is that? Let us see, right? For the table to be in second normal form, there are two requirements. One, as I said already, the database is to be in the first normal form. If it is not in first normal form, then I cannot go for the second normal form. Next, non-key attributes. Non-key attributes means other than the key attributes, right? The primary key or the foreign key, right? Non-key attributes in the table must be functionally dependent on the primary key, right? So anything, right? For example, the previous example I said about functional dependency, your author name and author phone number are functionally dependent on the primary key. It is must. So non-key attributes in the table, non-key, what are the non-key attributes in the previous example? Author name and author phone number. So these are the non-key attributes that must be functionally dependent on the primary key. It must be functionally dependent on the primary key. What was my primary key in the table? ISBN number or the author ID or the author publisher ID, right? So it is functionally dependent. It must be, right? Functionally dependent on the primary key. Good. So let us take this. How to decompose? If the data item, right, is fully functionally dependent on only on part of the primary key. If it is fully functionally dependent on only on the primary key, move the data item and the part of the primary key to a new table, right? Good. Next, if the other data items are functionally dependent on the same part of the key, place them in the new table also. Good. So make the partial primary key copied from the original table, the primary key for the new table, right? That is very important. Whenever I'm creating a new table, that table must have a primary key, so that like other columns will be functionally dependent on the primary key as well. So we'll be repeating this till we can do it, right? So let me give some example for you. I have your title, publisher ID, author ID, price, right? Author address, all those things. These are the tables, right? Now here in this table, what is my primary key? Probably like I can take an author ID or a publisher ID or anyone I can take, right? Now, if I take like this key, what can be the keys here? What are the possibilities to make it as primary key? Title, yes, it is unique and it is also not null. I can make this. This can be this order in the race, right? Title can be one primary key. Yes, publisher ID can be one primary key, and author ID can be another primary key. These are the possible primary keys, right? So I can either take my publisher ID or an author ID or a title as my primary key. Now let us see which are the things that are functionally dependent, right? Now here, if I say a price is dependent on author ID, publisher ID, and title, yes, I can say this price is dependent on three columns. Now when I say author ID, it is dependent on the author ID. Who is dependent on author ID? Only the author address, right? So for other things, it is not required. When I say for price, right, for author address, right, it is not dependent on publisher ID. Author ID, author address has nothing to do with publisher ID, and author address has nothing to do with title. Now here, these are the three possible primary keys. These are the possible primary keys. So among these three possible primary keys, author address is only dependent on author ID. But when I say price, it is dependent on all the three, right? It is dependent on all the three. Right. So what is the second normal form? A non-key attribute, right? What are the non-key attributes here? Author address and price. Two things are my non-key attributes, right? We have three key attributes. What are the title, publisher ID, and author ID, right? These are the possible key attributes. Let me say K to mention these are the possible key attributes. And your author ID is a non-key attribute because it is not dependent on anything, right? And then this is a non-key attribute, right? So we have three key attributes, possible key attributes, that is title, publisher ID, and author ID, right? And then what is the rule of second normal form? A non-key attribute must be fully functionally dependent on all the key attributes. Now here, when I say price, no problem, it is dependent on, it is fully functionally dependent on title, yes. Fully functionally dependent on publisher ID, and fully functionally dependent on author ID, right? Okay, no problem. This is qualified, right? Now here, when I say another non-key attribute, author ID, it is fully functionally dependent on author ID, yes, good. Is it fully dependent on publisher ID? No, author address have nothing to do with publisher ID, because it is the author's address, nothing to do with publisher ID. Then is it anything dependent on title? No. So this is not fully, what I say, author ID is not fully functionally dependent. Okay. Now, when it is not fully functionally dependent, then it is not in, then it is not satisfying second normal form. So not satisfying second normal form. So when it is not satisfying second normal form, what is that I need to do? I need to divide my table. How will I divide my table? Now here, price is dependent on title, yes. Price is dependent on publisher ID, yes. Price is dependent on author ID, right? So we'll be dividing it as title, publisher ID, author ID, and price as one table, and one more table that will have your other things, right? Now here, the new schema. What is your new schema here? Before it was title, publisher ID, everything is there. Now here, title, publisher ID, author ID, and price as one table. Another table will have author ID and author address. Now here, no problem. I have something to relate. How will I relate these two tables? Yes, with the help of author ID, right? So I can relate these things with the help of author ID. This is how I relate the table, first table and the second table. Even though I divide my table into two, yes, I can join it with the help of author ID, and it relates those two tables. Right now, here my table is divided into two, and both satisfies second normal form. Both are in second normal form. Yes, here if I take price, it is fully functionally dependent on all key attributes, and when I take author address, it is fully functionally dependent on all attributes. You with me? This depend on everything, right? So now here, without any problem, this table is fully functionally dependent, and this table is also fully functionally dependent. Now, no problem, both the tables satisfied second normal form. Hope you got it, right? Next we are going to see third normal form. Now, what is this third normal form? This is another level of normalization, right? First, we have seen first normal form, second normal form. Now we are going to see third normal form. So when my when I have to be in third normal form, when my tables have to be in third normal form, what is that I need to have? It should be in first normal form and also must be in second normal form. If my table is there satisfied first and second normal form, then I can go ahead with third normal form. If it is not satisfying any one of it, then I cannot come to the next stage. That is not at all possible for me. Okay, now here, let me read it for you. This form of normalization dictates that all non-key attributes, again, we are talking about non-key attributes, all non-key attributes of the table must be functionally dependent on the candidate key as well. So when I say candidate key, it is the possible primary key. And there can be no interdependency among non-key attributes. This is very important, right? In second normal form, what we have seen, all the non-key attributes, all the non-key attributes must be fully functionally dependent on all key attributes. Third normal form, no two non-key attributes can have relationship, right? No interdependency among non-key attributes. The non-key attributes cannot have interdependency. If it is there, then it is not said to be in third normal form. Okay, let us go ahead. Now, for the table to be in third normal form, two important requirements. What is that? First, table should be in second normal form. Yes. What is the next one? Attribute is transitively dependent. No attribute, right? There should not be any attribute which is transitively dependent on primary key. It means that no attribute cannot have any other relationship. It can have relationship only with the primary key. Okay. Now let us say how to decompose. Now, if I want to decompose the table, right, if it is not satisfying any of the thing, what is that it has to satisfy? One, it should be in second normal form. Two, no attribute is transitively dependent on the primary key. If it is transitively dependent on primary key, then you are not in third normal form. If at all it is not satisfied, what I need to do, I need to start decomposing. How will I do it? Move all item involved in transitive dependency. Whichever item is transitively dependent, move it to a different entity, that is create a new table, right? So when I say entity means table, right? So I'm going to create a new table and then store the data inside that. Okay, good. The next, identify a primary key for the new table. That's very important, right? So every table, make sure that you're having a primary key, or else you cannot identify the tuple in the table, right? The primary key is the one thing which identifies the entire tuple of the table. Good. So one thing, you need to move the table, create a new table, and two, after creating a new table, for the newly created table, you must have a primary key. Find a primary key for that, and then place the primary key for new entity as a foreign key on the original entity. Right now, here, if it is a new entity is there in the new table, there should be another entity which is relating to that is your foreign key. Okay, so I have a foreign key so that I can relate both the tables. Now let us see how to decompose again with an example. So here, let me give an example where I have building ID, contract, fees, right? Now these are the things schemas I have. What is that? Building ID, contractor, and fees. Now here, primary key. What is my primary key here? My building ID is my primary key. Now, when I say building ID is my primary key, it is must that your contractor must be dependent on primary key. Yes, fully functional dependent. Fee is should be dependent on primary key. No problem. Fully functional dependent. One more problem that we have: contractor is a non-key attribute. Correct? What is the thing in third normal form? No column must be functionally dependent on a non-key attribute. Now here fee is dependent on contractor. Now in other sense, I can say fee is transitively dependent on building ID. Right? Now the fee column, the attribute fee cannot be dependent on contractor directly in this table. If it is so, then it is not said to be in third normal form. Now I can say not 3NF. It is not in 3NF. So when it is not in 3NF, when it is not in third normal form, I have to start decomposing it. How will I do it? That is what we're going to see now, right? Now I'll say I'm going to convert my already existing old schema is having building ID, contractor, and fee. Now here, the new schema, I'm going to divide, that is building ID and contractor. So this is my table. Now here, building ID and contractor. This is my primary key. Yes, no problem. This is my primary key, and contractor is fully functionally dependent on building ID, and there is no other column to do it, right? Good. What is the next new schema I'm going to divide? That is your contractor and the fees. Now contractor is fully functionally dependent on, sorry, fees is fully functionally dependent on contractor. Here my contractor is my primary key. Now here, since my contractor is a primary key, here it's going to be my foreign key in my previous table, so that I can relate your DALF. It is getting related here, right? In Gersol, right? I'm relating it here, right? And then one more person, I'm relating it here. So this is how we're related, right? So when I want to give information, what will be the cost that Rodolph is going to charge me is $1,200 or rupees or euros, whatever you want, you can fill it there, right? So this is how I'm going to divide my table, and then I make sure that nothing is transitively dependent to the primary key. Now here your contractor in this table is fully functionally dependent on building ID, and here fee is fully functionally dependent on my contractor attribute. No problem at all. Hope you got it, right? So let me give another, let me go ahead and we'll see BCNF, that's voice code normal form. Right. Now, BCNF does not allow dependency between attributes that belong to candidate key. Very important, right? It does not allow dependencies between attributes that belongs to candidate key. Yes, that's one important. Like, what is candidate key? A key which is possibility of having a primary key status, right? If at all that key is not a primary key, then it's said to be a candidate key, right? Why do we call it as a candidate key? The reason is that if at all you're going for an organization, right, for an interview, right, if more than one people will be coming for interview, only one person or two person will be selected based on the requirement of the organization. Now here, all those people, those are waiting for the company to recruit them or call as candidates, right? Now, for example, if you're, I'll give a better example for that. If at all like election is coming, right? For a single post of MLA or an MP, right? You have more than one people contesting for that, right? So only one person can be qualified as a legislator or a member of parliament, right? So when I say only one person can be can become a member of parliament, and other people, right? Other people those are contesting, they are called as candidates. We don't call them as MP, right? We just call them MP candidate, right? So if 100 people are contesting for it, 100 people can contest. They are qualified to become an MP, but only one person will become an MP. That is your primary key. And other people those who contested to become a primary key are just called as candidate keys. Good. Now, BCNF is a refinement of the third normal form, right? As I said already, it's a refinement of third normal form in which it drops the restriction of non-key attributes, right? We had some restriction of non-key attributes that is getting dropped here, right? In the third normal form. Now here, the third normal form and BCNF are not same in the following conditions are true. What is that? One, table has two or more candidate keys. This is one thing. And two is that like at least two of the candidate keys are composed for more than one attribute, right? This is one thing. Another thing is that the keys are disjoint, that is composite candidate keys share some attributes, right? It has to share some attributes. So these three things are very important when we talk about like BCNF, right? The third normal form and the BCNF are not same when the following conditions are true, right? If all these following conditions are true, then it is not same. Okay, good. So let us see how to decompose in BCNF, right? So place two candidate primary keys in separate entities. When I know like I have more than one candidate keys, one primary key, one person who is qualified to become a primary key, what I'm going to do, I'm going to take that person, right, or take that candidate key and put it as a separate entity and place him as a primary key. That is the first thing that I'll be doing, right? For example, in a table, I have more than one column or qualified to become a primary key. Take one, put it in one table, take another candidate key, put it in another table. So you have two people or primary keys now, right? Got it? Right? I'll repeat again. If I have a column, or sorry, if I have a table of 4 columns, of which 2 columns are candidate keys, what I will be doing, create two new tables, take one candidate key, make it as a primary key for the first table, take another candidate key, make it as a primary key for the second table. That is the first thing that I'm going to do. Next, place each of the remaining data in one of the resulting entities according to its dependency, right? So what are all the remaining columns, remaining non-key attributes or remaining non-key columns? Place it either in the first table or in the second table, depends on the what dependency of the columns to the primary key. Okay. Now let us see an example. Now here I'm saying I have a table called as client, problem, and consultant, right? Now here, what are the keys here? Possible keys or client and problem, right? This is key one, and the key two is the client and consultant. So non-key attributes, hence third normal form. Right? It is non-key attribute, so it is there in third normal form. So then the client and problem are dependent on consultant, and the client and consultant are dependent on problem. There is a confusion here, right? How will I divide it, right? Because there is a confusing pointer here right now here. But what are all the possible primary keys that we'll be getting? What are the candidate keys will be there? So dependency between the attributes doesn't belong to key, then so it is violating the BCNF, right? So since it is violating the BCNF, we may need to divide the table. Now how I'm going to divide the table? Let us see that. Now let me convert the BCNF. The old schema is client, problem, and consultant. Now the new schema is going to be client and consultant. That is going to be here, right? So the clients and the consultants are resulted here. And second schema is the client and the problem, right? Now here I have divided these two tables and I have properly divided, and it's going to relate to each other. So client and the problem is getting related. The client and the consultant is getting related, right? Because of it is not there in BCNF, I'm decomposing it, dividing the table, and giving you the result. Right now, at this stage, my table is in BCNF, right? That is B box code normal form. So fourth normal form. Let us see what is fourth normal form and how to decompose it. Right. The fourth normal form eliminates independent many-to-one relationship between columns. So if I'm going to have independent many-to-one relationship between columns, then you have to take care of it. That is very important, right? And two, to be in fourth normal form, what and all need to be done? A relation must first be in BCNF. Yes, that is must. If I want to check whether it is in fourth normal form, first thing is that it should be in, it should have satisfied BCNF. Now next is a relation may not contain more than one multi-valued attribute. If it is going to have more than one multi-valued attribute, then you are violating the rule, right? So let us see how to decompose things. Now if there are more than two multi-valued attributes to separate table, right? Move it. If at all I have multi-valued attributes, better move it and separate it to two tables. Now then what we need to do after separating, one important thing that we are seeing from the beginning till the end, find a primary key for that particular table, right? Let us see that an example. Here we have a schema. For that, we have a movie name, screening city, and the genre, right? So what would be there, right? Let us see. Now, what are the possible primary keys? Now, here we see that everything can be a possible primary key, the movie name, the screening city, or the genre. Now, a column or part of only candidate keys. All columns are part of only candidate keys. Yes, hence BCNF. Good. Now, many movies can have the same genre. You cannot say that, for example, a movie X is of is an action genre, right? And if the movie Y is of action genre again, movie Z is of again action genre, right? So you cannot say that one movie cannot have a same genre. You cannot stop it, right? Yes. And many cities can have the same movie, right? You cannot say in one city you can have only one movie to be running, one movie to be screening. I can screen more than one movie, and then it violates the fourth normal form. Fine. Now what should I do? I have a movie name, a screening city, and the genre. Now here you can see that New York is getting repeated, correct, in the screening city, and this is supposed to be a primary key. Not possible, right? A primary key cannot have duplicate values. It must be unique. And moreover, I can also make this genre as a primary key. Now here, comedy is getting repeated, drama is getting repeated. No, so these two are violating, and it is not in BCNF. So these two columns violate the rule. Since it is violating the rule, I cannot consider it to be proper. Sorry, it is not BCNF. It is violating fourth normal form. I'm sorry about it. Right. So it is not in fourth normal form. Since it is not in fourth normal form, I have to start working on it. How will I do it? So let us see how to work on it. How to decompose. So convert to third normal form. Sorry, convert to fourth normal form. That's a typo there. Pardon me about that. Right. So now I am dividing movie name and the screening city. Now how will I do it? If I say divide movie name and the screening city, and divide movie name and the genre, right? When I say divide movie name and the screening city, here screening city, I have Los Angeles, New York. Sorry. Yeah, I'm dividing it as movie, that's, and the genre, right? And then I'm dividing it to another table, and then I'm dividing it as movie name and the screening city. That's how I do it. Okay. Let me give another example for you. Now here I have manager, child, and employee. All these three things are like qualified to become a primary key. Now everything is like here you are violating the fourth normal form, right? When I say I want to decompose it, first I'll just divide the manager and the child, and then here the repetition is getting avoided, right? Here you saw the data is getting repeated. Mary is getting repeated twice, right? And you have a null value there, and here you have all these data there. Now it is getting violating the rule. Now what I do, I just decompose, having manager, that is Jim and Mary, child, I've given that, and then the next I'm just making manager and the employee. So this is how I do it. Now here employee is your primary key here, which is not repeated, right? Nothing is repeated there. Now here manager is your primary key here, right? So now your problem is getting solved, right? So let us see what is fifth normal form. The fifth normal form is satisfied when you break the table till you cannot break it. You break it to as many tables as possible. One table can be broken into as many tables as possible, where you avoid redundancy, right? Completely when you avoid redundancy, right? So by dividing it again and again and again continuously, if you're going to divide your data into tables, bits and pieces, right? And then you feel that there is no redundancy is there, then your table is said to be in fifth normal form. which it cannot be broken further, right? Once it is done, you feel that it cannot be broken further. Anyway, it is stopping. That is the full stop. Then you go. Then you go for. Then you are. You. It means to be that you are in fifth normal form, right? And make sure that nothing is getting changed, right? Your meaning of the data should not get changed. You cannot keep on dividing unnecessarily, right? So the data can be divided or based, like there should be some qualified, it should be qualified, right? Enough, right? Yes, it is disqualified, right? You cannot keep on dividing where there is no meaning at all, right? You cannot divide further where there is only one column in a table. No, that's not possible at all, right? Minimum there should be two columns in a table, then only you can relate with the other table, right? So make sure that you're not dividing it, make sure and say that I have only one column, that it be meaningless, right? Any table is divided to a only one column table, only one attribute table, then it is totally meaningless. When you divide, yes, you can divide to avoid redundancy, but and some at some point of time you cannot avoid all the redundancies, right? So at some point of time you may need to feel that if it is no further can be divided, if at all I divided, it is not going to give me any proper meaning, stop it there, right? You should not proceed further. That is what we call it as fifth normal form. We can divide it till we get a proper meaning for it. Okay. Next, and the final one is domain key normal form, right? So domain key normal form is the one which the normal form, right, used in database normalization, which needs particularly that the database contains no restrictions, right? It contains no restrictions. When I say my table is the database which have the table is said to be in DKNF, it means that there are no other restrictions other than the domain constraint and the key constraint. These are the only two constraints that are allowed, right, at the last, right? So when I say my table or there in DKNF, it means that it's satisfied two constraints, that is domain constraint and key constraint. Now, what is this domain constraint? What is this key constraint? Now, domain constraint identifies clearly the permitted and enabled values for a given attribute, right? What can be the value for that particular given attribute? So that is called as domain constraint. Clearly identified what is permitted, what is not permitted. For example, this column can take only numbers. I cannot put a character there, right? So this column can have only 6-digit values. Yes, that is permitted. But apart from that, nothing is permitted. Again, when I say key constraint, it identifies clearly the attribute that declares identify the row in a given table, right? It can be either a primary key or a foreign key or any key that identifies the value. So these two constraints must be there. If these two constraints are there, then it is said to be in domain key normal form, right? I'll repeat again, domain key constraint is all about giving a restriction for a particular column. For example, what kind of value is permitted, what type of value is permitted, right? How big the value is permitted. All these things are set by the domain key. And what is the key constraint and how it identifies the entire row. So these kind of things are set by the key constraint. Okay. Now, if the table is in DKNF, only if it is in third and fourth normal form and other normal forms, right? So if it is not in fourth, third, second, and one, then I can never go for DKNF. Got it? So it is must that we need to follow all these procedures. These are the major normalizations that are available. As I said already, normalization is very, very important for any relational database management system because I want to keep my data safe, secure, redundant free, right? All these things are there, right? Then I have to go for normalization. If I don't go for normalization, then I'll be getting repeated data. People will be in a confused state, which data is for what, how I'm going to use this data. And if at all I'm going to have more than one value in the single cell, that doesn't look nice. So we keep on further customize our data, right? We keep on further, right? Make it clear to the user, right? Because if I'm going to have redundant data, the user will get annoyed and irritated. He may feel that he will go for the flat file system, which is very cheaper when you compare with relational database management system. So relational database management system, when I buy a software, when I buy something from the as a commercial software, right? I want that to be qualified enough for me because I'm paying money and getting it. It's not I'm not getting it free of cost, right? So if I'm going to rely on it and someone is going to give me support and all those things, and I'm paying a hefty amount for that, and you say that I don't care about anything, no, you cannot do that, right? So redundancy, data redundancy is a very big problem in any database, right? So if I'm going to have redundant data, I don't know which data I'm going to take it from and which data I'm going to use it. So this normalization is very, very important. As we seen in fifth normal form, we divide it further, further and further, and some point of time we may lead or end up in having a non-meaningful data, right? An irrelevant data. So these kind of data, right, we cannot take it as it is, right? So this must be avoided, and it is must that we need to take care of all these things, right? So don't be keep on dividing further and further. If you're going to say that I want to have normalization further, 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 and you finally end up in getting into trouble. So when I feel that you're getting into trouble, make sure that you are not dividing it further. I have to stop at some point of time. Now, what is that point? When I'm going to stop it and when I'm going to bring it back, that we are going to see now. So if I've divided further and I cannot divide anymore, or I feel that it become meaningless, then what should I do? I need to do a denormalization, that is bringing it back to the same position. For example, I have a table and I divided my table into 5 pieces, divided my table into 5 different tables, and some point of time it become meaningless. Now, what I need to do? If my table become meaningless, then I have to bring it back that and join it together, join my tables together, and that's called as denormalization, right? So it is a database technique, right? It is a beautiful technique where we can bring it back. Now, if at all I'm not doing it, then I have to be very good enough in using joins, right? So when I say I'm using joins and I'm going to join these two tables with the query system itself, yes, you can go ahead, but you will end up in writing big, big queries, and it will become a very big headache for the developer to do it, right? So it is always better to feed, if you feel that your tables are becoming meaningless, if your tables are getting divided to an extent where it cannot be divided any further, make sure that you are denormalizing it back to the same place, right? That is what suggested by all scholars. Better if we feel it is no more further meaningful, again denormalize it, bring it back to the same form, right? So in this video fully we have seen about relational database management system, that is actually the one of the wonderful database management system that is used in this era, right? So hope you understood this. That's it for this video, guys. Thank you very much. If at all you like this video, please give it a thumbs up and do subscribe to my channel.